Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Geometry makes up almost one-third of the test questions. Standard 8.G.1. Understand congruence and similarity. Please pause and read the details of this standard.
Hello and welcome. Here is what you need to know before we get to the examples.
What is a translation?
A translation is sliding a figure from a position in the coordinate plane to a different position. Here's an example. This triangle, figure A, is translated 11 units to the right and then 8 units up to get figure B. Figure A and figure B are identical. We call them congruent.
What is a reflection?
Mirroring, sometimes we say flipping a figure across over a line. Here's an example. Figure A is reflected over the x-axis to get figure B. Here's an example where figure A is reflected over the y-axis to get figure B. Again, figure A and figure B are identical, congruent.
Reflection rules.
There are some reflections rules here. They're really simple. For if you are doing reflection across the x-axis, what happened at this point is going to come here. So x stays the same, y becomes minus y. If you are doing reflection across the y-axis, y stays the same, x becomes minus x.
What is a rotation?
Turning a figure certain degrees about a point. We are interested in 90 degrees, 180 degrees, and 270 degrees. Here's an example. Figure A is rotated 90 degrees clockwise in this direction to get figure B. Again, figure A and B are identical, are congruent.
Rotation rules.
Here is a very interesting, important rules to remember. If you're doing 90 degrees clockwise, x and y are going to change positions, but the coordinate going to the right, because you are doing 90 degrees clockwise, it changes its sign. If you are doing 90 degrees counterclockwise, again, xy changes positions, but the coordinate that is going to the left changes sign. 180 degrees, that is really simple. xy goes to minus x minus y.
Notes.
270 clockwise, if they ask you to do 270 clockwise, that means in this point, I'm going 270 degrees to this point. It's the same as 90 degrees counterclockwise. If the question is 270 degrees counterclockwise, 270 degrees counterclockwise is the same as 90 degrees clockwise.
What are congruent figures?
Congruent figures are identical twin figures. They have matching angles and matching sides.
What are similar figures?
Similar figures have matching angles, but not necessarily equal sides, proportionate sides.
How to obtain a congruent figure?
A sequence of rotations, reflections, and translations applied to a figure produces a congruent figure.
What is a dilation?
Increasing or decreasing the size of a figure without changing its shape. Here is an example where this triangle, figure A, is decreased or reduced to figure B in size, and this is A dilated by a scale factor of 1/2 to get figure B. Here, figure A and B are similar but not congruent.
How to get a dilation.
To get a dilation of a figure, simply multiply all the coordinates of its vertices by the scale factor.
Final note.
Dilation changes the size of the figure and keeps its shape. All other transformations keep the size and the shape of the figure.
Example 1.
Quadrilateral ABCD is rotated about point P to create quadrilateral EFGH. Select all of the statements that correctly compare the two quadrilaterals. So I have all of this, but when you read select all, that means there will be more than one possible answer here. So if I look at this here, I can start matching edges here, matching sides. See, I see this one is clearly is this, and this one is clearly this, and this. Now, once I do this, it's now easy to see what's happening. Is AB equals to EF? Is AB equals to EF? Yes. Is DA equals to GH? Is DA, as one point here, is DA equal to GH? To GH? No. Is CD equals to FG? Is CD equals to FG? No. Is BC equal to FG? Is BC equals to FG? I had the three dots here, lines here, small lines. That's yes. Is CD equals to GH? Is CD equals to GH? Yeah, see, 4 and 4 lines, small lines here I put. And that's it.
Example 2.
Triangle ABC is rotated and then translated to create triangle DEF as shown. What is the length in inches of side EF? I mean, you can see how this is really straightforward, simple. What you can do, you can rotate this back this way if you want, and then you can see what is matching what. So obviously, this here is the same as this 6. This is 7, the longest of the edges, and this is the smaller of the edges. I mean, you can do it this way too. See, that's 4. So obviously, the answer is 6.
Example 3.
Penny has a pool in the shape of trapezoid ABCD as shown with lengths in feet. That's this one here. Ben has an identical pool trapezoid EFGH, but he is rotated as shown. What is the length in feet of sides EF? Of sides EF. Now, if the question was of side HE, that would be really simple. That would be easy. That would be nice if it was like that way, because you can get 10 very easily. This one here is obviously is the same as this. So we're identifying some of these angles and some of these edges. Now, this is the very smallest of the all angles. Acute. This is the same as this. So now when you see this, see the 10, this angle is tying 10 and 5.8. So necessarily this should be 5.8.
Example 4.
A series of translations, rotations, and reflections is applied to triangle 1 to create triangle 2 as shown. What is the measure in degrees of angle X? Now, this one here, you need to do some work, okay? What I recommend to do is, if this is 7, that's facing this angle 42. So this will be definitely 42. Now, this 8, this side 8 is facing angle 57. So this should be 57. Now you have a triangle, 2 of its angles are given, and I know the sum of all interior angles are 180 degrees. Don't forget this rule. So now you put X plus 42 plus 57 is equal to 180. Add these two numbers, subtract 99 from both sides, x is 81.
Example 5.
Pentagon A is rotated 180 degrees about its center and then translated to create Pentagon B. What is the value of x? This is really nice, giving you a question like that, very simple. I mean, you can see this is 100, this 100, these two will be 100 and 100. I mean, very, very easily, this is the same as this is 110. So the answer is clearly 110. So questions like that, be careful not to lose it because it's really easy to do.
Example 6.
An architect designs floor plans for two houses. The floor plans for the houses are shown. House B is a reflection of house A. What is the value of x? This is again one of the questions that are really given. It is really easy to do. I mean, obviously this here is the same as this, obviously, okay? Now, if you want other sides here, this one here will be 38, this one will be 24, this will be 22, 15, 16.
Example 7.
The two quadrilaterals are shown where quadrilateral EFGH is created by reflecting quadrilateral ABCD across a line and then rotating it. What is the value of x in units? He wants x here. So don't rush to answer this question like that because you have two options, 4 or 6, and you can easily make a mistake and a simple question like that. If the question was to find EHG, that's very simple. If E is required, is asked, then that's 12, and those are easy to find. Now, x could be this one or this one, so we have to do some work here. See this angle here is rectangle, is a right angle, the same as this right angle. Now I'm sure this one is equal to 6, not equal to 4.
Example 8.
This is another example which is really simple. A company created a logo using two hexagons. Hexagon PQRSTU is a translation of hexagon ABCDEF. What is the length of line segment TS? TS, obviously the same as this here, which is 4.
Example 9.
Quadrilateral MNOP is reflected over a line and translated up as shown. What is the value of x in degrees? I mean, you can immediately guess the answer, but to make sure, I mean, that we can put some information here. This is 50, that's the acute angle, the smallest of the angles, 50. This one is a 70, and this 130 obviously is 130.
Example 10.
This one requires some work. Isosceles trapezoid ABCD is shown. It's rotated to create trapezoid EFGH. This one is rotated to create EFGH. Obviously, he's not giving me that trapezoid. Which statement is true? So you have 4 here to choose one of them. You can't really guess. You have to do some work here. So you can do this. You can put ABCD, ABCD, and the other one is EFGH, EFGH. And now you can look here. Is EF parallel to HG? Is EF parallel to HG? Look up there. Is AB parallel to CD? No. Is angle A the same as angle F? Is angle A the same as angle F? No. Is angle B the same as angle H? No. Is FG parallel to EH? Is FG parallel to H? Is BC parallel to AD? Is BC parallel to AD? Yes. Okay, or you can do it in this way. Put EFGH here. It will be a lot easier. Or you can trace this figure on a paper and put it on the side here, rotate it this way, you can see what's going on. But this is maybe an easier way of doing it. So put E, F, G, H. And now look at the questions. Is EF parallel to HG? Is EF parallel to HG? No. See how you see it really quickly here. Is angle A equals to angle F? Is angle A equal to angle F? No. See? Is angle B equals to angle H? Is angle B equals to angle H? No. Is FG parallel to EH? Is FG parallel to H? Yes.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.